Hey everyone, so this will be the first video covering content from Year 10 Algebra. I'm going off the Australian syllabus, and the first thing we get exposed to when we do algebra at this level is adding and subtracting algebraic fractions. So I won't go too much into the intuition behind adding and subtracting fractions because I've talked about this more at length in a previous video, which I'll leave as a card. But here we're just bringing together the concepts of algebra and working with fractions. And we'll see in some harder examples, we'll even be bringing in some ideas from our previous videos in terms of algebraic expansion and expanding the brackets. Not quite in this video, because in this one, I just want to give you a bit of an introduction into this topic, and we'll do some harder problems in the next video. So I have an example here, which is 9x over 2 minus 8x over 2. Now, the first thing to note here is that you will see that we have the same denominator. So our fractions are almost, we can think of them as speaking the same language. So we are thinking in terms of halves. Now, we have this luxury that these are the same terms. So we can express the numerators, we can express these operations between our numerators as one whole numerator over the common denominator that both of these expressions have. So we can write this now as 9x minus 8x over 2. And we'll notice here, from what we know about algebra, we have two like terms here. We have a 9x, and from that we're subtracting 8x. And because of that, we can simplify this, write this in the simplest form by just doing the algebra, by collecting the like terms. So 9 lots of x minus 8 lots of x will just give us 1 lot of x over 2. And when we have the same denominators, whether we're adding or subtracting, we can just work with our numerators all over the common denominator that we're given. So in our next example, we are going to look at working with different denominators. Now, I'll actually make these a little bit. No, actually no. We'll work with this example. So, as I said, if you need a bit of a refresher, I do have videos up on adding and subtracting fractions with different denominators, like the case we have here. So feel free to have a look at that. But I'm looking at this, and we need these to be the same number. We need a common denominator to be able to work with adding and subtracting fractions. So we need a number. We need to make 5 and 7 into the same number, essentially. We need the same denominator. So we need the lowest common denominator. So the lowest number that both of these go into. Now, in this case, our lowest common denominator would be 35. So this is the lowest number that both of these can go into. So I essentially want to make these both 35. So how can I do that? Well, I'm going to write this fraction first, and well, I want to get 5 to 35. So how can I do that? Well, I can multiply by 7 on the bottom here. Now let's pause for a second, because I can't just multiply something to the denominator and not to the numerator. And the reason for this is because this won't produce an equivalent fraction. I've talked about this at length in my video on equivalent fractions, but we need to express this as an equivalent fraction. That means that we can't change we can't change the fraction. So we can't change the denominator without changing the numerator. So we multiply both top and bottom by 7 on 7. Because let's think about this. What is the effect of multiplying by 7 on 7? Well, this is kind of just like multiplying by 1. This is some kind of mathematical gymnastics and manipulation that we're doing to this number because we're changing this fraction, but we're making it into an equivalent fraction. So a fraction that's just expressed differently, but it's still the same number, just in a different form. And in the same way, we are going to subtract x over 7, but we're going to multiply both numerator and denominator by 5 to produce another equivalent fraction. And then this will allow us, this is that mathematical gymnastics I was talking about, because this enables us to have a common denominator, which will allow us to add and subtract our numerators. So let's multiply top and bottom now, and we'll see what we get. So on the top, 3x multiplied by 7 will give us 21x. And that's going to be over 35, which we wanted, right? Because that was our lowest common denominator. And from that, we are going to subtract here. Well, x multiplied by 5, we are going to get 5 lots of x, so we can write 5x. And then that's going to be divided by 7 multiplied by 5, so we'll get 35 here. And now that these two we can think of, well, they're speaking the same language. Both of these are expressed as fractions with an equal denominator. So now we can work with adding and subtracting these portions. So we can leave the numerators all together as an expression over the common denominator. So we get 21x, and from that we're subtracting 5x over 35. And we will end up with 16x over 35. And we can't simplify this any further because there's no common factors on our numerator or denominator. So that is our final answer. So just to give a quick recap, especially when dealing with different denominators, we still approach our algebraic expressions in the same way. So we are just finding a lowest common denominator and then doing our addition and subtraction. And the fact that these are algebraic terms doesn't really change our method from what I've talked about in previous videos about adding and subtracting fractions. We still approach it the same way. It's just a little bit trickier because now we're dealing with algebraic terms. So we need to combine our knowledge of fractions with our knowledge of algebra. So we'll work on some trickier examples in the next video. See you there.